Hey guys, welcome to day 7 Transformations in Spark. In this video, we'll be understanding select, filter, and with column. These are like some of the basic operations that happens with Spark, but the way to look at it or even the code is different. In last video, we have learned what are data frames. So you have to have a data frame development mindset. You can consider data frame to be a table having rows and columns, and there is a data type defined to it. This helps Spark to distribute it properly and take the advantage of the storage. There are two major issues while a person tried to develop in data frames. A person who is coming from the background of Java, .NET or those type of functional programming languages, they try to code in an ETL way. Then there are other type of people who have traditionally come from ETL background, those who have worked previously on SSIS, SSRS or those type of things, even Teradata for that matter. Most of them deal with long SQLs. For both of them, building the data frame, they both of these buddies try to build data frame related codes in Spark in their own way, resulting into the performance issues. So we need to have a right set of mind to build with data frame APIs and Spark. We need to work with data frame APIs and Spark. They are quite simple to use, but extremely complex operations are abstracted from us. So you need to understand each of the API. Data frame APIs are immutable. So after each of the transformation, they would create a new data frame. So how to handle that data frame? Considering data frame to be a table, we need to be able to play with rows and columns. We'll go in much detail with examples of how to build that mindset, but let us start with the small. What is the best way? Create a data frame from various sources. Keep modifying the data frame as per the logics. Keep storing the data in new data frame and understand what is happening underneath. Finally, save with optimization. This 5 pointer is heart of any Spark data frame code that you are going to write. So you always have a data frame which is created out of data coming from multiple sources. Let's say you have created, you are receiving the sales data and you have created a data frame called df sales. Then you do perform certain operation on top of it because you wanted to understand like what is the aggregated north region score and what is the aggregated south region score. So you perform certain transformation, and after that you can perform filtering as well. By mistake I just put both of them, but we can perform filtering and then we can select that only show me the north and all, like that. So this is how the data frame mindset goes, and then we save the optimized version of the final table. So this diagram is self-explanatory, and in the mind you always have to think that every time some operation is performed, a new data frame is created like this. So keep this picture in mind. Let's start writing our first data frame. Since yesterday we learned the data frame APIs and we created data frames using CSV, JSON and Parquet, we also understood schema, how to count rows and how to perform the basic checks on data frame. Now let us understand these three operations in detail. One is select, filter and with column. For exercises, we are going to take a CSV called sales.csv. It's a simple CSV. I have posted in one of the in uh, one of my notebook the data as well. One of my cell of the notebook, the data is also pasted. You can understand the data from here. Now let us try to understand with simple example. So we'll first create a simple data frame from the CSV file which is placed in our volume. So now the command is running and the data frame is getting created. Let us wait for it. Maybe the cluster is running, cluster is acquiring the machines, so it sometimes takes 1 or 2 minutes, but once it's ready it would work. So yeah, you can see the data frame is created from my sales CSV. Now let us try to understand our first transformation, which is select. This operation is almost similar to your select operation in SQL. It picks columns from a table. df.select is an API. So dot select is an API, and dot select is a method for data frame API, and then you can specify the columns within that. Whatever columns you specify, you would be able to view them. So for example, let's say you just wanted to view uh, df.select and you just wanted to view region, you can view region column. There is another way you can here you represent the name of the column. Now this is another way where you can specify it like an like call, and then within that you can give a column name, specify it in like a object, and to that object then you can perform certain operations as well. So if you have this, it's a column object, and then you can perform any operation to that. So let's say you want to uh, put a tax of 20%. So if you run this, you should be able to see a 20% tax. Okay, and let's say you wanted to see the original revenue column alongside that, that is also possible. So it's a comma separated. Let's run this, and you should be able to see region revenue, and this is a revenue with tax. So an arithmetic operation is performed. Let's move. What you have noticed when you performed all these things is you didn't have to write loops. So generally, if you would have written such a thing in Python or procedural language like like C++, you would have to go through loops to do all these things. Spark, by creating a data frame and then using the SQL-like operations or SQL-like functions of data frame, internally performs everything. It hides that abstraction. Spark applies the transformation across parallel, and it's a massive transformation. Right now, the data frame is relatively quite simple, but there are tables with billions and billions of rows, and when we perform the select, it might have to even bring some of the columns from like 4 to 5 different machines. Internally, it would internally Spark would take care of all these things. We didn't realize, but such a big thing has happened behind. Transformation. Now let us understand the second transformation, which is filter. Filter transformation is almost similar to the where condition is SQL. So you put like df.filter, and on top of that, where you say that revenue is greater than 10,000, revenue is greater than 1,000, and then you show that. You can even make it like 1200, so you should see only a single entry. So in this way also you can represent, like you if you apply the filter df, you can represent the column object with df revenue, and then you can put any condition on top of it. Uh, the internally Spark could apply that condition to each and every row of the column, and it will return only those rows which are satisfying the condition. Even within the filters, you can apply complex filter condition like df.filter, and within that you can apply this complex filter condition where you write down that okay, particularly this is greater than 1,000 and region is not equal to south. So like that you can manage. This is important transformation called with column. What happens is when you are building a code in Spark and data frame, as I mentioned in the starting, that you need to have a big data a data frame way of mindset to build such program, where you know that after each and every transformation a data frame will be created. And in such cases there are many scenarios in which you would have to generate an additional column, with which we sometimes call it as derived columns. Those who come from the background of ETL, they would know the importance of derived column. So for such thing, with column is very important function. The with column method lets you create a new column or replace an existing one. Now this is a basic implementation. So we have created a new column called discounted revenue, and from what we have created is like we use the original column revenue and just multiplied uh, with multiplied it with zero point 0.9, and then eventually you would get a completely new data frame. So what just happened is a revenue a revenue data frame which is stored on across the cluster on multiple machines with column would add an additional column on top of an existing data frame, and to that data frame it is going to create a completely new column with new value. So this is what we'll see. Okay. So each and every row will be replicated. The operation will be performed with each and every value of a row, and a new column will be created. This is an extremely important type of operation, as I mentioned. So every time some transformation you have to perform. So for example, there is a date format, right? Like some date is not in a right format, and you need to have a correct format. Then in that case, definitely, uh, data frame is the way. With the with column operation is something that you can use. So this is the date which is not in a proper format, and then you convert it into a proper format. So such operations. So you can imagine like any such operation where you had to create a new column, with column would come handy. Chaining transformation. This is an extremely important thing. So you can always, you as I mentioned, right, you just don't apply single transformation. You keep on applying transformation, and your data frame changes its state. So this way, Spark has given a beautiful thing called chaining transformation. What happens is you can chain the transformation. So for example, df dot with column, then df dot filter, and then df dot select. This transformation would happen in this sequence. So in this data frame df, a with column, new column will be added called revenue with tax, and then the new column will be filtered with the condition, and then some particular data will be selected to be shown to the user. Let's rerun this. Let us simply try to change the calculation so that you can see the value is running. Yeah, yes, you can see. So this is how it works. So in just few lines, we have learned adding a new column, we have applied the filter and selected only few columns. These are like very basic operation, but these are like something to get started. Think of data frame like a conveyor belt in a factory. Select is like a choosing which parts to build on or which parts to keep built on. Filter is like removing defective items as they pass. With column is like adding a new label or tag to each item. Each step adds to the plan. It's not like single step is not sufficient. That is there, but then in ETL you always need to perform these transformations one after another. Only way you finally ship the build is by calling an action like .show or .write. In the last video, in last to last video, I think we have seen what are transformations and actions. So this way you can perform the transformation, and then finally an action is being called which has created the result. Today we built our first transformations in Spark using select filter and with column. This is a bread and butter of Spark programming data engineering student. From now on, every data frame pipeline you write will rely heavily on these three methods. So these three are like basic methods. You need to know this. So you must practice it a lot. So you have officially written your first basic Spark transformation. In the next video, we are going to learn about actions in Spark. So we have learned transformations in Spark, which doesn't trigger the action, and data. Next, we are going to learn actions in Spark. So stay tuned and thank you for watching. Please do subscribe. Thanks.